If you consider the example of a balloon, okay, when you inflate a balloon, it starts out small, all right, and then how do you get it big? If you want a big balloon, you have to do what? You put more air in it, right? So here you have less air, here you have more air, right? In order to get a bigger balloon, you have to pump it full of, you have to put more air in it. Pretty simple concept. But if we think about this in terms of the, what's actually happening, the less air and more air, that's talking about, the number of particles, right? The amount of the gas that we're putting in there. So we could say the moles of the gas, whether air or any other gas. We have fewer moles, all right? And moles we represent with the letter N. Okay, so here I have N1, N2. I am increasing my moles, so my initial condition has fewer moles than my final condition. I've inflated that balloon. Okay, so what happens to the volume as I increase the amount of gas in there? I put more gas in there, and we're assuming that the pressure of the small balloon is going to be about the same as the pressure of the more inflated balloon, okay? So that the constant pressure we can ignore, but we see that the initial volume also increases with the moles, okay? So just like we did before, we have a proportionality. Okay, volume is proportional to moles. And is it directly or inversely proportional? As the moles increases, so does the volume. So that is going to be a directly proportional relationship. Okay, so volume is proportional to the moles, and we can then write that as volume equals, again, some arbitrary constant times moles. Then, just like we did before, we can divide both sides by n in this case to solve for that constant. And what we have is the volume divided by the moles is equal to some constant. So however much gas I put in there, the volume will change, so that when I divide the volume by the moles of gas, it's equal to a constant. So my final conditions, when I divide those, will equal to the same value, the same constant, as the initial conditions when I divide them. All right. So here I have a relationship V1 over N1 equals V2 over N2. And this one is Avogadro's law. Okay, so we've talked about three different laws in these three segments. We have Avogadro's law, we have Boyle's law, and Charles' law. I call them the ABCs of gas laws. You have Avogadro, you have Boyle, and Charles. Okay, three different laws relating the different aspects of of the gases. Avogadro, think Avogadro's number, you're thinking moles, right? So that's volume and moles. Okay, and then Boyle's law is volume and pressure. Okay, and Charles' law is volume and temperature. In each case, we can write it like the V1 over N1, V2 over N2, V1, P1, or typically P1, V1, equals P2, V2, and V1 over T1 equals V2 over T2. Those are the three laws. But we're going to kind of look at this and we're going to put these two together. And because we'll see, okay, if Boyle's law says that volume times the pressure or is equal to a constant, volume times pressure is constant, and Charles' law says volume divided by temperature is equal to a constant.